Hello, in this part we are going to talk a capacitated transportation problem. This may happen occasionally that we may have a road problem or vehicle problem so that from one orange to the other destination we have trouble to use the regular shift schedule. So this time, how may we deal with it? Let's look at example 6.5. Here we have 3 oranges and 4 destinations. And we suppose that the shipping link between orange 3 and the destination 4 has an upper bound capacity of 12 units. That means we can only have 12 units at most to shift from orange 3 to destination 4. Now we still want to minimize the total shipping cost. You probably say that we may not, maybe we don't need to have some units from orange 3 to destination 4. That's possible, right? So, but if we have, how may we satisfy that the upper bound capacity of 12 units? Now let's look at the left of the screen. You could see I make up the table from the data we got, and you could see that on the column 4, that's the cost from each of the orange to that. You could see from the range 3 to market 4, we have the cheapest price. So there is a possibility where with normal that schedule, we have some goods just shift from range 3 to the market 4. So we are going to work on that directory. Okay, now first of all we check the amount for demand and for the supply. And you could know that we have 100 total units in supply and we have 95 units in demand. So in this way, that means we have to set up a dummy destination, right? Okay. Now right now we don't consider the upper bound. We just see if we can find the solution. Now we use the Bojo's method, work on it. Okay, set up the 5 dummy destination, and we use Bojo's method to work out it. Then you could see the not just difference between that the cheapest cost for row 1 is 5, and then row 2 is 3, row 3 is 4, and columns, the first column is 2, second column is also 2, and the third column is 1. The fourth column is 1, and the fifth column is 0. So here you notice that when I put this modules, I already read the details there. When I circled which one I work on first, I have the very small number on the left above. You can see that first we choose 5, so I use the 1 there. When we choose 5, then 0 is the smallest. So 5 is the first row, and 0 is the cheapest price. So we put 5 there. Then the column 5, the fifth column is crossed. And then we recount that the difference between cheapest price and for the rows that row 1 is 1 and row 2 is also 1, row 3 is 2. And then we the for the each column except the fifth column, all those differences keep the same. So the next step, I choose the first column to work on. So when I choose first column, work on it, and then you could see 6 is the cheapest one. So we put total 15 to that to cell 31, and then the first column is done, and then that the orange 3 have 35 only, so I crossed 50, write the 35 there. Now once we crossed the first column, and then we have to recount the chips, the difference between cheapest price. And in this way, you could see we crossed the column, first column, and for those column 2, 3, 4, there's no changes for the difference between cheapest price. So we only need to recalculate the difference between cheapest prices between that among those rows. So in this way, you recounted that the first row 657, the difference between the cheapest price is 1, and the second row is 1, and the third row is 2. And now I continue to work on second column, the columns. So second column, you can see there is a 3 there. So I put the 3 on the 2. So in this way, the cheapest one is 4. So I put 20 into it. And then this column is done. And so far, when we work out it, the orange 2 has 10 units left. So I cross 30 to have 10 there. And then we have two columns, column 3 and column 4. So we still have the same differences between cheapest prices for column 3 and 4. And then we recount that the cheapest prices on those rows. So here we count row 1 has 2 and row 2 the difference is 6, and row 3 difference is 2. So we work on that row 2 first. And row 2, you could see that 3 is the cheapest one. So we put the remain 10 from orange 2 to it. And then the row 2 is done. And once row 2 is done, you can see the rest on orange one has 15 left, so we put that 15, and then row 2 has, and third row has 35, right, in the orange 3, so that 35 will fill out it. Then we have top row 1 under it. Top row 1, we have that basic variables is 1, 3, x13, x15, and x22, x23, x31, x34. So you could see this one. When we have this one, how many variables do we have? And 3 plus 5, so 5 m plus n is 3 plus 5. Then minus 1, we should have 7 basic variables. Do we have 7 basic variables? It seems we don't have 7 basic variables, right? So here we have to set up one basic variable with 0 value. What I set up is the here, that is the 0 here. So we set up a basic variable with value 0. That means there is a degeneracy because we have 6 basic variables. We do not have enough because in this tableau we have m equals 3 and n equals 5, right? We should have m plus n minus 1 basic variables. What so far we have only had that 6 basic variables. We want to calculate all the values for dual variables, and then if I settle that x14 equals 0, then I could connect with that x1, x34. Of course, you could try to use that x11 to be the 0, and you probably found you probably cannot go further. The reason is that this is already reach optimal cases. Okay, now let's see what's going on. So once I set 7 to be x14 to be 0, and then v1 appears most. So I set v1 equals 0, and then I get v2 equals minus 2, v3 equals minus 1, and w1 equals 7, w2 equals 6, w3 equals 5, w4 equals 7, and w5 equals 0. And then we calculate vi plus wj for those non-basic variables. So for x11, v1 plus w1 equals 7, and we just continue to work out it. And in this way, you could find out that actually for all these non-basic variables that vi plus wj minus cij or less than or equal to 0. So in this way, we already reach optimal solutions. What you could see that actually from the orange 3 to market 4, we have in usual schedule, we need to put 35 units there. So we shift from the orange 3 to the market 4. Now, what if we have this upper bound capacity of 12 units from orange 3 to destination 4? We have to rework on that to just see if we can just put 12 units from orange 3 to the market 4. Okay, now what we do is here you just look at I already wrote that the total cost in this case in the usual time. Okay, what we need, the total cost is 485 at x1 equals 15, x2 equals 20, x2 3 equals 10, x3 1 equals 15, x3 4 equals 35. That means from the orange 1 we shift 15 to the market 3, and from the orange 2 we shift 20 to market 2 and 10 to market 3, and then from the orange 3 we shift 15 units to market 1 and 35 units to market 4, right? So as usual, we simply ignore that one in the dummy column, right? Now, how may we build up tableau when we have this bound capacity? So what we do, we look at the tableau. What we do is we simply separate the 50 from the original 3 to 12 and 38. The 12 is the upper bound capacity from original 3 to destination 4. And then we just add one more row in the original tableau that is for 38. That 38 row you could see on the bottom of this tableau, and all the prices from the orange 3 to other markets are the same, except that one from orange orange 3 to market 4. This one we put the price is infinity. That means if we want to minimize the total shipping cost, we definitely want to put any units there because it is infinity. Whenever it is not zero, then the cost is unbounded, right? So here you can see that when we set up this one, on the third row we just separate the orange 3 into two rows, right? One is 12, limit 12, one is limit 38. So for this 12, that one, we keep the orange price, that's 6, from orange 3 to market 4. So in this way, we have a new tableau. And how to set up this new tableau is normally because from the above, you couldn't know that in the normal schedule, we would ship 35 from orange 3 to market 4. So here, because the upper bound of 12 units, so here when I started this one with Vogel's method, I simply put the 12 from orange 3 to market 4 on the third row, okay, here. So once we set up this, we simply click and just cross it. Okay, we cross this one, we put it there, and then we use the regular way to work out the rest of the tableau. So in this way, you will never put any units into that 4, right? You won't. And actually, that once we done this, and you can see here we do the same thing with use Vogel's method. That's 5, 3, 4, and here for this one, that is what this one first one, that is first one is 1. Here should be 1 here. From here you can see that 6 is gone. So the difference between the cheapest price on the fourth column, you can see the cheapest price not 1, and between two cheapest price is 7 to 9, so that should be 2, right? So in this way you can work out it. Just continue the same way to work out it. What you do is first put, so this one, the key is you put that 12 to there. Sometimes if we have a road broken, we probably couldn't put any goods from orange, some orange to the other orange as usual schedule. So if we have this kind of problem, we simply put that infinite cost there, and then we continue to use Vogel's method to work out. Or of course you can use the minimum cost method to work on it. Now if we continue to work out it, and then you can see we find the new tableau, and we work on it, and then we found that's the one we needed to work out it, and then we have x4 entering and x15 departing in this part, and this is the optimal solution, and you could copy it when we work on it. So that's use the regular way to work on the tableaus.